the lesson we did Friday, we're just checking if things are congruent. So if you understood Friday's lesson, it shouldn't be too difficult today for you guys. But let's get started there. So first of all, what is a rigid transformation? What is so special about rigid transformations, translations, reflections, and rotation? What makes them so unique? Who knows what a rigid transformation is? Yeah.
It's like a transformation along the line where the sides don't change.
Yep. The size and shape do not change. So today we are going to use these rigid transformations to determine if two shapes are congruent or not. So go ahead and flip to the next page when you are ready. Okay, are the following pairs of figures congruent? If so, what is the transformation needed to map one onto the other? So Dylan Keith, is that first one there congruent, first of all?
Yeah.
What transformation could you use?
Translation.
Yep. Ben, how about B? Is B congruent or not? Are the two triangles there congruent? What? No. So these two are not congruent, so we do not have a transformation. They are not the same size and shape. Brandon. C. Nope, one square is bigger than the other. Melinda, how about that last one? Are those congruent? By what?
Rotation.
There you go. Very good. It was turned. So if it's not on an actual grid, you won't have to tell me like the numbers or anything. You just have to tell me like is it a rotation, translation, or reflection. So questions on those ones before we look at the next ones there. Yeah, Alan.
A, could you say it was a reflection to
That is not a reflection for A. If it was the same, like, do you see if you reflected this one, this would end up over here?
Oh, yeah.
But if it was like the same shape, like a rectangle, rectangles you could use a reflection or a translation there. Does that make sense? Okay. I think you could also do 180 degree rotation with that too, depending on what point you do it over. All right, so show that A and B are congruent through a single transformation. Write the rule for the transformation. So we need to map A onto B. We need to map A onto B. Madison, what transformation would map A onto B?
Translation.
Can you tell me the rule for that translation?
X minus 2, y minus 3.
So let's see if she is right. So you said x minus 2, y minus 3. So if we go left 2, down 1, 2, 3, that puts us in the same spot. So is her rule correct? Yep, very good. That proves that those two are congruent there. Okay, Paige. How can A get onto B to show that they are congruent? How many degrees? Rotation of 180 degrees. Doesn't matter if you say clockwise or counterclockwise because we'll move 2 quadrants either way. But it moves 2 quadrants, right? Do the slopes stay the same? Up 1 over 1 is this point and this point. Very good. Up 3 over 1. Down 3 over 1 is this point and this point. So those are the same, right? This point here is up 2 over 4. So we go down 2 over 4. Is every point mapping with a 180-degree rotation? Did Paige do a good job with that choice? Yeah. So just make sure you're checking things that they line up right, but that looks fantastic to me. Okay, show that A and B are congruent through a single transformation and write the rule for that transformation. Jordan, map A onto B. Are they congruent, and how do you know?
A reflection over the y-axis.
Yes. So it is a reflection over the y-axis. So if you look at this point here, it is 1 away, and so is B. If you look at this point here, it's 2 away, and so is it in B. If you look at this point here, I'm sorry, that one's 3 away and 3 away. If you look at that point there, it's 2 and 2. So you'll notice that it folds evenly along the y-axis. So questions for that one before we move on to some compositions to prove that they're congruent. All right, so show that A and B are congruent through a composition of transformations. Write the rules for the transformations. So what do you guys want to do first to show that A is congruent to B? We got to get A onto B. What would you want to do first, Alana?
Reflect over the y-axis.
The y-axis? So first we're going to reflect. So reflection over the y-axis. So that point there is 1 from the y, so it needs to stay 1 from the y. This point here is 4 away from y, so I need to stay 4 away. This point here is 3, so I need to stay 3. This point here is 3, so I need to be 3 away. And then finally, this point here is 4, so it needs to stay 4, and I can connect my points. Now what? Now what could we do? Anything. Just tell me what you're thinking. Melinda.
Reflection over the x-axis.
So we're going to try a reflection over the x. Make sure that when you're doing these problems, you're using pencil. Because sometimes you're going to make mistakes and things aren't going to work for you. So it's not a race on who can get the least amount of compositions to get there. I just want you guys to get one onto the other. So if somebody takes 10 steps and another person takes 2, it doesn't matter as long as they're both correct. Does that make sense? Okay. So this point here is 1, 2, 3, so I need to go 1, 2, 3. This point is 2, so I need to go down to 2. That point's 2, so it needs to stay 2. Red is 3, so I need to stay 3. Purple point is 1, so it needs to stay 1 away. Feel like I might have done something wrong. No, I did not. Okay. So that looks like that. After the reflection. Now what can we do? Now what can we do? Tucker, what would you do now? Want to reflect over the y again? So reflection over the y. You guys are taking the long route to get here. Don't forget that you can reflect over like x equals 2 or y equals 3. Isaiah, seriously. Reflect over the y-axis. So remember, you can do like y equals 3 or x equals -2, right? You don't just have to use the axis. It's fine that you're doing that, but just don't forget that. So when I reflect that, the points end up as so. What could we have done first instead to get to that same spot we're at right now? What? Yeah, we didn't need to do all 3 of those steps up there. We could have just reflected to the x-axis right away, but it's okay. It does not matter that you guys did that. Just for future reference, there are typically shorter ways than doing it that way. So Dylan Deptula, what would you do last there? Okay, tell me the rule for that translation. Okay, so give me it as like x plus something, y plus something. What is it? X is it? So it's y minus 1, right? What is the x? So you went down 1 over 1, 2, 3, 4, 5. So that would be x plus 5, right? Because it's going to the right. So we go 5, down 1, right 5. All right. You are on the wrong one. Look at the image you drew there. The image that's on there. All right, maybe we can do this next one a little bit quicker. We'll find out, right? Okay, Mariah, we need to map A onto B to show that it's congruent. What would you do first for this one here?
Translation.
Where?
Up 2.
You want to translate it up to? Anything else? Just up to?
Yeah.
Okay, so how would you write that as the rule?
X. And then comma y plus 2.
Okay, so we're going to try this first. So we're going to move everything up to. Ayana, what would you have us do now? What? Rotation how many degrees and which direction? $90 degrees counterclockwise is what you said, Ayana? Okay. So please pay attention if you're still struggling with rotation. So 90 degrees counterclockwise means everything moves 1 quadrant to the left. And in this case, so that means everything will end up over here. The slope is an opposite reciprocal. So this one is going up 2 over 1, so that's 1 over 2. We need to get to this quadrant, so do we need to go up or down? Up 1, left or right? Left 2. This point here is up 3 over 1, so that's 1 over 3. So we need to go up or down 1? Up or down 1? Up or down 1? Up 1, left or right 3? Left 3. Okay, this point here is up 2 over 2, so that stays 2 over 2. And this point here is up 3 over 2, so that would be 2 over 3, so 2 over 3. Now what, guys? Sophia? Since the points are not labeled, that is fine. If they were labeled, you would need to use a translation. But we don't know which points are supposed to map onto which things here, so that's fine. We're just proving they're congruent anyway, so that lines things up to show that they're congruent. Again, if there were like things like if this was labeled like X, Y, Z, you know what I mean? And then it was X prime, Y prime, Z prime, you have to make sure those letters match up on that to prove congruence. But there's no letters, so it's fine. All right, look at that next one for me. Some of you guys aren't there yet, so I want to make sure you're okay. Saw some of you drawing this line in here to show the reflection over it, so if you need to do that, you can. Are those two? So it says show that A and B are congruent through a composition of transformations. So we're going to show that they're congruent. Brandon, vote. What would you do first to get A onto B?
Probably a reflection of the x-axis.
So we're going to try reflecting over the x-axis. So each of those points needs to stay the same distance away from the x-axis. Cameron, what would you want us to do now?
Couldn't you just reflect it over the X again?
You reflect it over the x again, it's just going to put it back onto itself.
Then you reflect over the Y.
Okay, so we can try reflecting over the y. You guys take the long way for everything in this class. You guys need to get it going up and down, right? Do you see that? Do you see how this one's going up and down and this one's going side to side? Or however you want to look at it, vice versa. So we do need to get it that way at some point. So that point's here. Here. So I'm just using the colors to show you where they go. Again, it stays the same distance away. So did that really help us yet? How can we get it facing the same direction? What do we need to do? Sophia? You want to try the reflection over y equals x? That just means you switch the ordered pairs. Okay, so this is 1, 1. So it'd stay here at 1, 1. So I'm going to recolor that in. This is the point 4, 1. So that would become the point 1, 4. Four to 2 would be 2, 4. Good. This is the point 3. I think 3, 3. 1, 2, 3. 3, 3. What does that then do? Just stay stays right there. And then finally, this pink point here is 1, 3, so that becomes 3, 1. Okay, now I have to try to connect these correctly. 1 second. So red goes to pink. Pink goes to yellow. I'm going to use a different color. So red goes to pink, pink goes to yellow. Then I just jut in and come up. So are we still the same way? Are we the same? Are we the right way yet? No, this is taking us forever. But we can do some reflections now to get us the same way, can't we? Can we do some reflections to get us the same way now? What can you reflect over? What could you guys reflect over? Brandon?
X-axis.
Okay, so let's reflect over the x-axis. Okay, can we then reflect over, I'm trying to get this so that we're almost done here. The line 1, 2, can we reflect over the line x equals 2.5? Let's try to finish this up here. So let's reflect over the line x equals 2.5. So that is 1.5 away, so that puts me over here. This is, I'm sorry, I should draw the line in. 2.5 is right through the middle here. So that's half away, so that goes here. Yellow is half away, so that goes there. Red is 1.5, so that goes there. And pink is just half away, so it stays half away. And I'm going to change my line back to black. Now, can we just use a translation to slide that on top of the other one? How many up does it have to go? How many up does this one have to go? How many? How many up?
5.
5?
Yeah.
This piece here has to go all the way up to this piece here. So if it goes up 1, it's not on that top of that piece. So it goes up 1, 2, 3, 4, 5. Does that make sense? So x comma y, x doesn't change, y goes up 5. What could you guys have used to make this a little bit easier than all these reflections? Huh? A rotation would have been a really good choice here. If you would have rotated this 90 degrees counterclockwise, it would have ended up the right up and down direction, and then you could have reflected it from there. Do you guys see that? Don't be afraid of the rotation. The good one. If it's not facing the same direction, you're probably going to need a rotation. Yeah.
Just like when you reflected over the just like do y equals x and then another difference.
Yes. Well, you reflecting over y equals x did a good job of getting it up and down as well. So even if we would have started with that and then used a couple reflections from there, that would have been good. So that choice was a good choice to get it going up and down too. But a rotation or that y equals x would have been a better choice to start off with, right? Do you guys see that? All right. Are these two shapes congruent? Are these two shapes congruent? This piece here and this piece here look the same, right? Through here looks the same, right? Does this outside piece look the same? Does that look the same? No. There's one here, and I don't even know what's going on here, but there's never two, right? Do you see how there's two full straight lines here? Do we ever have two full straight lines on this side? No, so these are not congruent, so we cannot map them. All right. So put not congruent. Look at it. Like, if you look at the pieces, this outside piece here, this only has one straight line at a time. This one has two straight lines here. Does that ever happen on this one? No. Do you see that? So I'm just kind of looking at the outside parts of the figure. Do you see that now, Ayana? Okay. All right, we're mapping A onto B if they are congruent. Are these two congruent, Hannah?
Yeah.
So what would you do first to map them on top of each other?
Reflect over that x-axis.
So remember, with reflections, you have to stay the same distance away from whichever axis you are reflecting. What could we reflect over now to get those on top of each other? What could we reflect over now? Lexi, what could you reflect over now to get those on top of each other? It needs to reflect to be on top. What is that line there? X equals -1, we'll put it right on top. You'd have to use a translation. So you could do that and then a translation. What could you use instead, though, than -1? Do you see how it's in between? If you go in between, it will be the same distance here. So it would be X equals -1.5. If you did -1, that is fine. Just make sure you do a translation afterwards. Tucker? What? Yeah, go ahead. So that then maps us back onto the other because X equals 1.5 is that line there. So that's half away, half away, half away, half away. This is 1, 2.5, so half and then 2 is over here. And the same with this. So do you guys see how that will get us right back onto that? Again, you could have used like X equals -1, or you could have even used the y-axis and then translated it. That's completely fine. All right? It's not a race of the least amount. It's okay if you guys don't get it the first time. All right, last one. Start plotting A, B, and C and W, X, Y, Z onto your graph. While people are finishing up that last one. And then I'll catch up with you guys. All right, guys. The first thing you have to check is, are these two even congruent in the first place? Are these two congruent in the first place? So the top has 1, 2, 3, 4, 5. This one has 1, 2, 3, 4, 5. So those look good so far, right? This has 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the bases look good, right? Let's look at the legs here. This one goes up 1, 2, 3, 4, 5 over 2. So I'm just looking at the slope there. 1, 2, 3, 4, 5 over 2. So does that look like they're congruent? So what can show that these two are congruent? What should we do to show that these are congruent? They're not facing the same way, so what thing can help you get it facing the same way? A rotation. How many degrees and in which direction? So if we do 90 degrees counterclockwise, this would flip on its. So we want to go 90 degrees clockwise, right? And notice W lines up with A, right? X lines up with B, Y lines up with C, and Z lines up with D. If you look at that in your polygons, you see how those are the ones that line up? So they must line up. So we're going to say 90 degrees clockwise and see if that works. Okay. Means they move one quadrant to the right. So A would end up here, right? It has a slope of down 3 over 1. So that's 1 over 3. To get to this quadrant, do you go up or down 1? Left or right 3? So that puts us on W. So this is looking good so far. B is up 2 over 1, and we need to go one quadrant to the right, so B needs to be over here. So that needs to become 1 over 2. Do you have to go up or down 1? If we have to end up here, do you have to go up or down 1? Up 1, right or left? Right 2, and that lines us up with X. C is here, so that means it's going to end up down here in quadrant 4. It's up 4 over 4, so 4 over 4 stays the same, but we need to go down here. So instead of going up this time, we're going to go down 4 and right 4. And then D needs to end up over here in quadrant 3, and it is down 5 over 4, so that becomes 4 over 5. So we go down 4 over 5. Do those map onto each other with just that rotation? Yes, they do. All right.